Okay. Good afternoon, everyone. I'm delighted to welcome you all to this Institute lecture series. Today, we have the privilege of hearing from Professor BHIM Singh, a highly respected Emeritus of Professor at IIT Delhi, whose pioneering work in power electronics and renewable energy has earned him the prestigious Vigyan Shri Award. To introduce Professor Singh formally, I now invite Professor Narayan Kurur to the stage.
Welcome. It's indeed a pleasure to introduce Professor BHIM Singh. And as is often the case, people would say that he needs no introduction and then go on for 5 minutes introducing the speaker, which I will also choose to do. Professor BHIM Singh needs no introduction to the Institute. He is an institution by himself. I will not go through the numbers which are there in the bio that was shared previously. I will give you my own sort of interpretation of Professor BHIM Singh. He graduates more students than many of us graduate in our lifetimes. And that's been the case for many years now. He continues to do so. And from my personal standpoint, when I ride my cycle and I hear a car whiz by with the license plate 1124, then I know that Professor BHIM Singh has left me in his wake. And that's a reflection of the numbers, I think, to a large extent. It's a very tough act to follow. The only thing that I have tried to do is to emulate him in his morning sort of walk. But then again, I have to follow him because he is out before I am. And he continues his not so leisurely walk after I leave. And when I'm coming back into work at a normal office hours, he has finished already office work and has probably polished off a few manuscripts in between. It's a very, very tough act to follow. I have other memories in that both his sons happened to be in the class that I taught, undergraduate chemistry. They were undergraduate students here in computer science. So the dictum that with every passing generation there is a regression to the mean does not seem to hold. Similarly, I also understand that his older daughter is a graduate of the AIMS Institute across the street. So his children have taken beyond where he is. So. Again, without much further ado, it's a pleasure to have Professor BHIM Singh here to deliver this lecture, which is a commemoration of his receiving the Rashtriya Vigyan Puraskar, Vigyan Shri, which was awarded to him a few months ago. Unfortunately, for various reasons, we couldn't have it right away. But better late than never. It's indeed a very, very great pleasure for us to have Professor BHIM Singh here. I'm not sure if he has given an institute lecture before. If not, again, it's indeed an honor for us to have you here, sir. Thank you very much.
Sir, I would request Professor Kurur to please be on stage and present Mr. Singh with the memento of honor.
After 50 plus years of service, this is a small token of our appreciation. Thank you.
Well, good afternoon to all of you. Thank you, Professor Kurur, for very nice words, and my dear friends, the faculty member. I'm thankful to the administration of IIT Delhi. I mean, probably to give, I mean, more than 34 years, and probably earlier also 6 years, here to being a master and PhD student. I, of course, take a flip of around 8 years at Roorkee and came back again 30. Well, so it's a really very joyful. Of course, Professor Kurur, correct, I not deliver any other lecture. I have arranged a lot of lecture as in his capacity as a Dean Academic. I mean, like, and thanks to Professor Subodh Sharma, who really changed up me probably for last couple of months. Somehow, so today we are able to make it. Yes, it is possible. Like, well, I don't know how much time is permitted.
You have
Hour 2.
hour to yourself.
Okay. Probably I will not bore you too much time. I will just share typically, like, I mean, this is the, because where here we have to really speak about, certainly we must have some technical topic. I mean, no doubt. I mean, like, but there are a lot of typically interesting funds I may have in between. So this is the area, of course, renewable. I started quite late in this area. Typically, you can call it like a, probably with the flood of last couple of decade only. Earlier, I started probably my career with a very classical subject with my professor here in on electrical machines, then going to typically on drive, then power electronics, then probably renewable is the last. And apart from, it's still going on something like that. Well, being in a different capacity of the institute, that was another experience. I mean, like, which probably, I don't know, many of my friends know that when I've come to administration, my academic output have been multiplying. I mean, like, in the sense, there's a great chairman twice, associate dean probably 3 times, then the probably head as a 4 times, and then dean academic, it probably gone to 8 times. I mean, counting my own output, not comparing with anyone. I never compared. I don't like to compare, because comparing means probably you are in some other buck, like, so that's something. This is the topic, of course, I have been working with my supervisor on probably a small hydro initially, which now picking up, because research is always, I believe, around 20-25 years ahead than what is in implementation. Of course, nowadays we have a less gap in that. So we started the small hydro, then we have gone for wind, because winds were blowing. Probably when Germany get united, they have to come quickly for the wind. They were in the typically to come, region being there, certainly, I mean, you can think about if we are getting pipeline from Iran and very good friend in between, then they stop the gas pipeline. We live in heaven, because you will not die even you are sleeping on railway station, but if you can think about in Germany, the person will be frozen in 3 hours. So they can't think about, like, they have to come up very quickly on energy, so they started wind. It was retrofitting, well down. We also work, I probably graduated around a decade, around a probably almost like a dozen of students in wind also. And after that, I thought it, why not to go probably for the solar, like, so last probably 10 years have gone in the solar with the around 25 PhD students and the applications, like, which probably I will be talking in very brief here, like, now. So virtually, of course, I have put the topic very general like renewable, but I will be confining to probably to the solar, like. In solar also we started, probably why I started, probably I think Professor S.N. Singh was the Dean IRD. He forced me to coordinate the project on solar with the SERB call, Solar Energy Research Initiative, like. I told him I don't work in the solar, but he says you can coordinate probably. So I have gone with my own project, with the 60 lakh of project, but the funding agency says you can increase, but we want implementation. I work hardware only. So they asked me to increase to 60 lakh to 1 crore. And probably 3 years to 4 years. We implemented it, then we go to another project with the SERB around 3 crore, they gave 2.5 crore, avoiding the overhead. Then of course it got multiplied, that we have been custodian project of 4 crore, 3 crore, typically, and even another project. I mean, our share, project have been 25 crore, 50 crore, all of that. So with this, probably 25 to probably total fund could have been around 50 crore. It was very difficult to digest 50 crore in this environment of our, where we work in very hardcore, typically very conventional area of electrical engineering. So I have to work out in different dimensions. Funding agency give only 2 manpower, 2 research scholars. So how you can expand? Then I have to certainly think about which really, I mean, to how you can get a good number of students, may not be good student, but good number of students, like. Then I have to think about where is the loopholes in the system. And loopholes certainly the part-time is sponsored, OBC, SC, all kind of, I mean, manpower I have to really collect, and then probably start looking into it, and then did many experiments in the research also how to get work out of and what is the best in particular student like. Okay, so that concept I really start putting, and up to some extent we have been reasonably successful. But the experiment with I have done with the manpower, really it was not so easy game. I still finding really difficult, but hopefully things are going okay. The last phase after retirement, I thought it not to look into, because I mean I do remember still when I have to organize the probably the meeting with Professor Ram Gopal with the faculty, and he always says all these publications will go to library. I was always thinking probably it's pointing towards me. Maybe right or wrong, that's a different issue. Then I thought it, why not to, probably many incidents, why not to think about looking little bit startup. So last 3 years I thought little bit, still half the way, journey is not full, but I feel that will be still successful in that also, typically. So in this area I have not taken any startup on renewable, but after last year, probably I think after declaration by government of 1 crore installation, I thought I think there is a scope for. So now probably I am thinking little bit on that direction also like. So I am sorry for a couple of minutes to bore you for 4-5 minutes, and now let's come to the what really we did in the solar in the past. And I was able to convince probably the custodian project also, because they were giving a lot of funding for development of solar cell. I am able to convince that we have to give some money for development of the system, because development is coming up in India also, and we have to modify the deployment in India positively. So some money have to put for that. And I asked my student to look into, if we are able to connect this our system, let's say solar system, to grid, and you develop the algorithm, probably you have to develop algorithm which never will fail in the world. You know why? Because our electrical system is so bad in India, grid is so bad, if you are able to work with, it will never fail. And really it is recognized in publication also, probably, especially we publish mostly in IEEE. So they recognize also it, yes, you are correct. In place of putting 1 algorithm or 2 algorithms, we have to put 3 to 4 algorithms for the same system. So it worked up to some extent without much problem. Then we extended the application of the solar into many like also. Well, another reason why I have to go to the solar, people say, I mean when I think I do remember 2012, Bull Power put a probably 2 megawatt in Moradabad, and they say it's tripping. I mean, because it's all the European inverters, they trip it because voltage fluctuation in India was wide. That's one. Another is these people start talking about this all solar inverter put the harmonics or create the power quality problem into the grid. And I say I'm putting my 25 years to work on power quality, which we supposed to claim around 10 years back to be number 1 in the world on power quality. And we say using this inverter, we say we eliminate the harmonics, and they are saying that this inject the harmonics. It means there is something wrong, either they are mad or I am mad. There is something. So research comes from that point of view. So then we start looking for, yes, what the kind of inverter. I will talk a little bit what really were appearing in that. So is there any problem with this? So we look initially not to disturb at all in the system, and we found inverter is lying this solar. So we thought it, why not to only modify the control, not to touch inverter hardware at all. So we thought of not to touch hardware or the experimental part, only to really look into the algorithm. So from there we started, and then we start looking at some practical aspect which really we face day to day in India, typically. And we have been reasonably successful into that. I mean, at the moment we have some industry project also now at very fag. Industry also believe in when your hair are white. Now, without that they don't believe on you, typically like, I mean. So now they are after us when earlier we have been after them, typically like. So coming with this, so I will go quickly. Of course, Professor is already. So this is, I think you can see the typically the why we have to go for renewable. I mean, the solar has gone probably 2013 when probably Haryana government put it, and it gone to really 199. Probably it is in probably still 2-3 years back. And that time my friend from US who is working in power electronics, he sent me the clip that in Middle East it's already 1 rupee per unit. I mean, here we have a 2 rupee per unit, but in Middle East already, because Middle East already deploys solar like anything, because they have a very much large air conditioning load, and probably that requires a kind of cooling like. So it means we all hope maybe next 5 to 10 years, and the panel cost, even if you look into last 3 years, I keep little data, I mean for doing a, so I was told that 3 years back the panel was 33 or 34 rupee per watt, and now panel cost has gone around 13 rupee per watt. So already going to be 1/3 cost of the panel, and that's the costliest item we consider it into that. So I mean, time is not very far. Probably it may come even 1 rupee per unit in India also. So you cannot deny the technology. Whatever the drawback this technology have, you have to adopt it, and you have to further improve according to your requirement. Of course, the wind I saw it, which when we started working wind was little then lower the solar, but in the last 15 years I am looking the wind, it's gone only from in India also 40 gigawatt to only 46 gigawatt. But solar, you can say here it was hardly not a probably a 3 gigawatt, but now we have been on 90 gigawatt. And the federal government decided to go by 2030, they want to go for 500 gigawatt. I mean, now we are around 100 gigawatt to 500. So they want to double the still electricity generation whole in India itself is 500 gigawatt, and they want to go 500 solar only 500 gigawatt. So they want to double the capacity. Another reason for this, for electricity generation, either you do by solar or any other means, this is one of the way. We have a per capita consumption of electricity in India. Per capita consumption, how much one person consumes in a 1 year, is only 1250 units, where the US consumes 25,000 units, around 20 times than us. In spite, the US have not gone completely on transportation, electric. I mean, they have not gone electric on the transformers. I mean, total is not electrified, the transport is not electrified in US also. So it means if we want to go electrified, in our requirement have to be further double to that, because 50% energy goes of the total energy into transport sector. So it means we have to be prepared. If we want to get developed country by 2047, whatever we call it or whatever number, it means we have to go 40 times electricity generation. And whatever we generate does not matter. And this is considered to be the cheapest electricity today. So certainly the maximum pressure will be on this technology of solar generation. Just to give you an idea why people should really think about the solar, why you will be interested to work on the solar like. So it means if we have to go 40 to 50 times in next probably typically 25 years, I mean hardly 23 years left for 2047, now 100 years of independence, because political system decide always these benchmarks like also. They decided earlier 100 gigawatt by 2022, 75 year celebration, but they couldn't go more than 50 gigawatt. That was the half the target. So even if you give the half the target, it will go, should be around 20 times the generation what we have typically today also. So that's the reason, and of course it's supporting. I mean, when of course India have a, what is in India I consider one of the best with us is the population, our requirement. I mean, everybody looks on you from the world that you have a good market. So if by improving the technology, if we can convert to the wealth, I mean for our own needs itself, forget about the export, I mean that will be a great market in all respect like common also. So looking this as a probably the figure why people should be motivated to work or to use it. I mean, of course, this is some data, maybe little old data. I mean, but they consider the renewable is at the moment is 41%, that typically 173 out of 417, but the figure are changing every day. I mean, if you have to say 500 gigawatt have to come by 2030, every month you have to add the 1 gigawatt probably of the solar, like no doubt also. So anyhow, these are the typical data. So I think I already explained why renewable and why typically, of course, this is with the pollution. I mean, solar you can say if it is a coal have a 820, I mean this equivalent typically emission, then here it is typically only 48. So it's typically, I mean you can think about very small pollution. So that's another reason why Delhi people should be more attracted. And of course solar can be put in Delhi also. Then it can meet whole energy requirement by solar itself. We have so many good canal or dirty nalas, even if you put on that, that will be more than enough the requirement of Delhi. I mean if people really wish. I was in NTPC board for 3 years as independent director, and I wanted to try, because their MD was reasonably, CMD is quite strong, otherwise also, I told just you do one thing, put a 1 rupee additional on electricity, and you will get too much money. I don't think we will take a loan from anywhere in the world, and you can probably put several plants, only 1 rupee. And reason justification I told him, no? If you talk about the gas, if you talk about the petrol, if you talk about the diesel, you know how much is the duty, excise duty and everything on it. I mean, either you call it whatever the taxes, these taxes are more than 50%. I mean like, so if it is a petrol is 90 rupee or 95 or 100 rupee per liter, 50 rupees are the taxes. And that can produce hardly 5 units of electricity. So 5 rupee electricity, if you are putting 10 rupee taxes, why on electricity you can't put by 1 rupee tax? If you put 1 rupee per unit, probably you will get a billions of probably dollar or rupees, and that will be enough to develop these plants without taking money from anywhere else, like also. But anyhow, that's a apart from, I mean, they were not at all in renewable, saying thermal, but now they are going also renewable. That was the probably triggering point typically for most of the, even NHPC also going triggering. And I was talking to, I think last month somewhere in some meeting with the CMD of the NHPC, and he said, we were talking about what will be the efficiency of the solar installation I am talking about finally. And they say, sir, by official and proper installation, we are able to get now 46% efficiency typically, which we consider around 12 to 15% at the moment in the field. So it means technology is changing, whether it is a bifacial or multi-layer solar will be coming in future. Apart from that, all the other system also coming day by day more efficient. And we expect that today, if it is a 15% efficiency in the field, probably may go 45 to 50%. Of course, we are interacting with the industry, and they say, if really you change the converter, we can get 5 to 15% more increased energy yield. And when we look into their aspect, what they were suggesting, and we are working on it, we found there is a need on the cell also to improve. You know, in the laboratory environment, we say that solar, I mean, cell can give a 40% efficiency. Why we are getting 15% efficiency in the field? Because never the power electronics people and typically the solar people sit together. They are working apart. So if you are connecting in a one module, around 70 cells, if one cell generate the less, all cell generation reduces. It means you have to give something with every cell so that none of the cell produces less energy like for power. Similarly, same thing is there in a one string. You have again 22 to probably 22 modules. If one module generate less, it reduces the generation of all. And that's the reason finally you are able to get hardly 15% or 18% efficiency in place of 40% efficiency. It's not that we say laboratory it will produce more or later on, but we have to look into the region because nobody work on that. Typically, we work, when we were putting a first installation in director launch 25 kilowatt, I was the chairman for committee, and then 2 megawatt here in the campus, which first megawatt given a big relief with a 400 air conditioner supported typically. Like earlier we are not able to, I was in air conditioning committee for 20 years and we are not able to give the air conditioner to the faculty even. And now probably you can understand every office with the air conditioning with the only effect of couple of megawatt on rooftop of solar, like. No doubt, like but anyhow, this suits very well. People come around 8:45, but solar comes around 6-7 o'clock in the morning, like and in the evening also people move 5:30. Sun remains in hot summer up to 6 o'clock. So it suits such a, installation like our campus. Also, I will talk about a little bit on that also. Going to be a part. Of course, we are lucky in India is whole on a good solar map. Around 4 to 7 units per kilowatt. Around 5 is the average. 5 units per kilowatt installation will give around 5 to 6 units without any problem. When we put first installation, we only take a commitment of 4 units. I told to take 5 units, like why not to take guarantee of 5 units, like. But they say, of course, some of member of committee says that they will install a little more and charge more, but we finally go, okay, 4.5 unit may be a good compromise. But they are not cleaning because commitment is already met. Why they should clean? We put around 7 lakh per annum to clean 1 megawatt panels, like about 46, typically, separate distributed, like. So anyhow, these are the typical photographs that which application it can go, like also. This is one of the interesting application, especially for India. You know, second largest consumer of the diesel in India is the telecom tower. We have a 5 lakh telecom tower. And why it become interesting that you can probably forget the meal, but you will not forget the mobile call. So these are all not electrified. They are not connected with the grid. That's why you will find the DG set. But government is pressing them hard. You know, we give the subsidy on the diesel on the name of farmers. The first largest consumer of the diesel is the railway, and second largest consumer is this mobile towers. So the government is pressing hard. Whatever you put in and solar here also, if you integrate solar, battery is already there in telecom tower. So probably you can easily integrate the solar into it without much problem and reduce the consumption of diesel if you can't completely eliminate. Of course, from a reliability point of view, you have to keep certainly the DG set also there, like also. So this is one of the important consideration for India because we have a large population, large number of mobile phones. And we have to still, 5 lakh towers are there, still there is a call drop. So it means we have to increase the number of towers further. And this energy requirement will further increase. So we have to look carefully that we have to really supplement. And the solar is every place, no doubt. we can't say that wind may be everywhere, but at least solar is most of the places like also. So other applications we work out is typically the solar water pumping, which I will be discussing a little detail. And this also, of course, I have seen the installation in 92 to 97 for solar and wind also. And I've gone to Central Electronics Limited in 92 when I came to the institute, and they were just experimenting the brushless motor like induction motor. But you know, I mean, this is the large, not only the irrigation, but there are plenty of applications probably for solar water pumping, like a drinking water supply, lot of application coming for this solar into the water pumping. We interacted, of course, with the industry like Shakti Pump. We don't claim that we are the developing technology, but of course, initially they came for a consultancy. We did consultancy of 13 lakh, and then they participated giving 1 crore into SERB project, like where we graduated around 10 PhD students on this. But when I've gone in 95 to the industry, I asked, are you having any patent? They say, what is that? I mean, like, and you will not believe now industry is how it is groomed in last 4-5 years after taking all this technology into practice. Last year their profit was 1 crore, and this year profit is 93 crore. Next year profit is going to be 500 crore, because they have ordered already 2,500 crore in hand. I mean, typically in the last 3 years how this has blown. And these are all government orders, like typical Kusum scheme, so many schemes from some states like Maharashtra, Haryana, as well as MP and Rajasthan. So they have a large number of orders, like they don't have any competitor virtually in that. And we given probably the technology we work on with them all 5 brushless motors, not on one motor. So I believe, because as being an academician, we look into the different possibility that I put probably 2 PhD students with every motor, brushless motor out of 5 motors, like, which I will be talking little bit in brief in that also. So this is again another application we really work out, and I was keen probably last 15 years on that also. We first did the project with the DST of 70 lakh, and then we have gone to consultancy of 13 lakh, and then probably 4.5 crore worth of project of Ustara, out of which industry gave 1 crore. Like. So anyhow, this is, of course, there are a lot of plenty of applications coming up. I mean, another application, of course, is standalone. This is virtually the application of solar panel on satellite. Virtually the mechanical MPPT I learned from it. Many of you might be knowing my student Professor Rajgopal, K. Rajgopal. He was the person to work on a stepper motor to place the solar panel towards the sun of satellite. In set 1B, the panel couldn't open with not enough torque of a stepper motor. And it was completely wind up the unit because it failed. And they start making from France the 2 stepper motor for one satellite. Where the person in MTech, he started this design and continued in PhD for stepper motor for this positioning solar panel in the satellite. This was mechanical maximum power tracking. But of course, there is electrical maximum power tracking. To a mechanical engineer, of course, in some industry, it took me half an hour to convince that there is electrical maximum power tracking also into it. So we have 2 maximum. But this is only required in some mechanical maximum power tracking, means positioning the panel towards the sun. This is only for few application. All application is not so much important, like also. So there are a lot of applications. Of course, people are coming, and Indians are very crazy to put every place. I mean, like military applications, even the person put on the back of the bag to have a solar panel. He is not able to connect probably in the entire bag or whatever the typically, gadgets he is having, electronics gadget to charge with, also. Of course, in India, people are caging just to put them in. People are able to put like 360 watt on e-rickshaw top also, and you can see, all the metro station from Faridabad line, I think which Prime Minister has inaugurated, has a 450 kilowatt panels on each metro stations, like. So we have a probably trains, we have a probably buses, we have a different vehicles, and of course, we have a typically railway station, probably all these where the solar is going to be deployed. I asked my research student to account for how much, as a very conservatively, we can think about how much can be. In India, we can probably put in different applications the capacity of solar PV. So we calculated around 2,560 gigawatt on different applications where maybe wasteland, MNRE says we can put 748. This is MNRE data of 748 gigawatt. And then you look into all applications, we look into carefully that how much gigawatt can be put with the different around typically of 13 kind of application, we look into, finally it comes 2,566, which is approximately at the moment is only 100 gigawatt, which is 25 times that. And 500 gigawatt we are planning by 2030, probably it is much. So probably it may be, of course we can further, because it can go higher, we estimated very conservatively. Maybe tomorrow panel efficiency, bifacial efficiency increases, it may go to double the capacity of this, the scope. So of course, I mean, this is one of the interesting kind of a concept from industry, that where panel and a small DC set. I don't know, many of you might be knowing an industry called Enphase. They interacted during COVID period online to me. They don't put the product on their website, but they showed me in their presentation and what the product they were having. The startup in California, San Francisco, especially 2006 to 2019, their stock was $6. And 2019 to 2021, their stock during COVID period have gone to $176 typically. And product was only rooftop of 3 kilowatt and 10 kilowatt with a small DG set and battery in the home for charging, meeting all the requirement including the charger. And second product, they were having portable power system, again with the capacity of 3 kilowatt and 10 kilowatt solar, plus a small DG set and battery for as a portable power system for different purposes, including the charging of EV on the spot where you want to take it like also. So there are plenty, of course, kind of that kind of product. And I hope, I will not claim that your Prime Minister, who was the Chief Minister in that time in Gujarat, he was the first to put 1 megawatt on canal top. When your stars are very positive, what people calculate. That time I saw the newspapers and what the reporter were reporting, that putting the panel on the canal, so much water will be saved. That is the benefit reporters were reporting. So much water will not be evaporated if you put on the canal, this solar panel, typically. And of course, this may be one technology, whether it makes there are plenty of technology in our area, which make the people, from fly to one place to another, typically. And of course, he was the first advocate for solar panel to put on canal. But it has a relevance in the sense that canal becomes the picnic spot after putting the panel. You have to put surveillance, everything on this with the proper security and all that. So no Bhavri Devi will be put after murder into canal. Once the solar panel put on the canal, it automatically goes in that manner, kind of. So anyhow, these are, of course, this is typically of course, the largest plant. I put it. This was the interesting, about 7.52 rooftop in Vyas. Many of you might be knowing. A lot of people live there after retirement in a community center, probably similar to Agra. We have typically satsang kind of community. Similarly, here Vyas also there is a community which have it. So they adopted this 7.52 megawatt around 10 years back as a rooftop installation. Well, coming to why we work out probably because this was the typically even 10 years back also it was reasonably hot area, and what research you can do in that. We thought it to start with. Of course, what existing is the string inverter. You put the panel in series and then you have a single here and put into the inverter and put to the grid. The another is you have a micro inverter. You have a small converter and then put one inverter to the grid. A separate inverter for each and put into the grid. And then you have an optimizer, maybe DC-DC converter and with single inverter put the grid. These are the three systems which are put in practice even today. But initially major installation of old are of this nature. And this has a drawback. It's called single stage system. You are using only inverter. After panel, you are connecting a string in series and then putting an inverter. You are not bothered that how each individual panel is or individual module is manufactured, generating light. But in this case, every panel have a small micro inverter. But micro inverter culture, of course, it is a costly because the cost is a very sensitive in this technology also. So micro inverter earlier was supposed to be costly, still is a costly. It's very difficult to put micro inverter and then put to the grid of little higher voltage. But now inverters start coming recently in last couple of years. But of course here this also start coming recently only because manufacturer, even those who have put already of the single stage, now big manufacturer like even Adani and all that, they start also thinking if you put only those, there is some kind of limitation. So I asked my student also 10 years back, we have to go two-stage system. So research goes in just reverse manner, typically. And two-stage means you have to put inverter as well as you have put here DC-DC converter. So it means cost will increase, efficiency will go down. That's the perception initially goes. But we have to break this concept through the research, and that's exactly we did. So there are, of course, these are some of the issues and plus advantage. So we, of course, divided as a total pattern as being academician that, okay, what are the possibility can we think about of solar system? Whether the standalone grid, of course, standalone are very few system, but grid interface may be single phase, three phase, like a rooftop, majority of single phase, and then three phase in many. Then we work out classification topology wise as well as control wise. We work out control wise in the sense only we have to modify the control like also. Of course, you have many concepts like standalone grid interface. And of course, I told you there is MPPT. Mechanical MPPT is not too much used. We have every place a direction in which you should put a panel towards that. But the electrical maximum power tracking, you have to really work out with that. You have to force the panel to operate when intensity of the light changes or impedance changes, that you have to operate on these curve only typically. Forceful lead. Maybe partial setting also there, still you have to work out like. So anyhow, these are a lot of maximum power tracking algorithm, and these are the typical system. Maybe battery, without battery also it can work like typically. So we work out, of course, the control which I mentioned little bit in the slide. We worked 25 years probably in power quality. The control algorithm which can be directly deployed here. Like also. So I asked my student to put into. This is the typical system, which single stage system, panel with the inverter and to put the grid. This is the system existing, and what I asked my student to modify it, of course the control of it to little bit improve of it, but the major factor which thought of, my student job was to put intelligence into it. They are the young blood. Whether AI, ML or whatever it is, this is one of the physical system, and they have to put. One of my student who was power system background, he says, I know a lot of algorithm. I don't know, whale optimization, odd column time, some of you might be knowing now, AI, ML tools. I told I don't understand all these. In the simulation, you put in practical implementation. Even for MPPT, if you can put, I will be happy. And I will give you the platform with another student. So they work out maybe around probably 10 transaction paper in 1 year with the team. And then this student PhD started. Like typically, now you can do it. Okay, also. So they put a lot of algorithm, all AI, ML here, and for control of these solar inverter, and work well. So what we thought it working with this, that okay, the solar inverter is supposed to be used not only for the purpose of, I will go probably next configuration, that probably will help to understand. So we put double stage, but what we put, this inverter is not to use only for generation of electricity, but use for additional function to operate it, use this power electronics 24 hours. Even when I go into funding agency, I told I will make a power electronics cost 0. You know, who is a good doctor? Who give less medicine. You consider that doctor very good, no? So being a power electronics expert, I told in this solar installation, I will make power electronics cost 0. And 20 people sitting in a committee, they say, how will you make a 0? A physical system is there, no? It costs is 25%. We are Indians. We will use it 24 hours for something else. Okay? If we take a person on overtime, no? We pay double. But even if you pay 2 hours to the guy, he will do a whole day work because that's a bonus for him. Salary is already getting, typically. So that concept exactly I put it here, to put into this. And we put 2 stage. Putting a 2 stage has given that this voltage need not to be very high. So, and we are able to maintain this voltage to vary within certain range, so that losses in the inverter reduces. Because now it is a 2 stage. We are adding this 3 component, loss increasing, cost is increasing. How to justify technically? Okay, yes, if you increase the cost and if you increase the losses and increase the size and weight, how justify it to installation? We look into, okay, we can change the voltage this level and inverter losses. We reduce the 5% losses here and add a 1% loss, still we are able to generate 4 to 5% more energy, typically. That's exactly, of course, I have probably the slide probably later, which really. So here we look into that this additional, this converter will compensate power factor at unity here, not only probably not generating the harmonics, but eliminating the harmonics of this additional load. And work as a reactive power compensator as well as react for harmonic compensator, and modify the control in a way even voltage varies over a wide range, the inverter should not trip. That's the additional function we put it. That's why I say, control should be so robust, even voltage is distorted, but current should not be distorted, kind of thing. So that's typically the, of course, the control. This is what we extended for 3-phase single stage system, and then we have gone for typically here, of course, 2-stage system here also, of course, with the additional function. And this was the concept that we put in, that if we really vary the DC voltage ripple in the current of the grid was less than this, and we are able to see in India we have a voltage reduction more, not to increase. So if voltage reduces, we are able to increase at least the generation by this extent. So losses, if we use our system, that was the generation. If we use the conventional system with constant DC link voltage, this was the generation. So we are able to increase around 500 watt, typically in 5 kilowatt, typically around 5 to 6% increase in it. And this generation increases more and more as voltage reduces. And this is a very common problem in India, that voltage reduces most of the time. Typically in distribution system. So this was the additional feature. We are able to reduce typically we are able to increase 500 watt. In spite we use the two-stage system. That was the typically you can call it, the research was well accepted. My students are able to probably manage this tool very well to twice it with experimental. These are all experimental, not the simulation kind of things like. Then we look into, we can compensate with this system to do additional task of compensation, so that solar may be not in the night, but this inverter works 24 hours for the compensation in distribution system. When we put a capacitor panel, it only increase the voltage, it cannot decrease the voltage, it cannot trap the voltage. But this inverter is capable to trap the voltage, within a certain limit in distribution system. So it provides the reactive power. Not only reactive power, it can do load balancing as well as harmonic elimination. So all the power quality what we work out for 25 years, we put everything into it. And that given additional features to work with this inverter without modifying the hardware. No additional cost of the hardware. Whatever we put in this DSP or control of it. No sensor increase, no cost increase, no hardware component change, only control is modified. Which added value in the sense that we are able to probably do on the distribution system, which otherwise, because we work for 25 years research in that, we are not able to put that probably the technology into the field because it was very costly. As far as hardware is concerned. But this hardware is already available with the solar inverter, we modify the control. And those features are able to take, we say that at least the cost of entire power electronics is taken care from that. And the payback period of the complete plant also reduces as far as the rooftop is concerned. So that's about the lot of control people, our student put to operate in over a wide voltage range, our solar intensity change, and to work it for 24 hours for those purposes. This was the rooftop. I consider the second applications I will like to little bit mention about on which we work on solar or pumping with all the typically 5 motors. This is typically can be one good storage. You can put in the typically time the daytime and use probably 24 hours. So there are of course many means for why it's, of course this is the some data 91 is started. Typically it was that much, but in so many years, but in 3 years itself it has gone to 1 point, but now it is already going to be every year more than 1, even 3 lakhs, which I had given the data. So it can be for, of course, spray irrigation as well as for typical water pumping, then equator, lot of swimming pool, lot of application coming up, municipality supply also, and of course for heating purpose and others. So this is basic configuration that we have a PV array. We may not have a grid, we may have a grid, then power converter and the motor pump. Interesting part is we have to do MPPT of the solar and then modify the typically speed of the motor to consume entire power. If it is a isolated case. If it is a grid interface, then you can take the power to the grid and you can feed the power to the grid. Of course, we work out with this why the conventionally people use the motor PMDC motor, but we work on the research on all 5 motors brushless. Induction motor, bounded brushless DC motor, reluctance motor, synchronous reluctance motor and PMSM. Even this motor we were working out, I started working in probably 84, 86 Roorkee, but the motor shape what synchronous reluctance motor is today is different totally. It evolved in last probably 5 to 6 years only, big industry like ABB as well as the Siemens start manufacturing this motor. So we work out all 5, 6 motors, we have to procure 4 motors from ABB even. I don't care from wherever the funding can take from anywhere from the world, you can take the best motor which can be. Like induction motor virtually 3 PhD, even 1 var from ABB work out. And we work out that why, one can question why all 5 motors? Why not 1 motors? The question is different rating the different motors are. If you talk about small rating, the BLDC may be the best. Like you want to put only a motor, submersible motor for drinking water supply, hardly 200 watt motors. Induction motor may be half HP, single phase, but BLDC will be hardly 200 watt. The rating may reduce by 60%. And that will reduce the panel size also. So even 3-phase induction motor, I asked a couple of my PhD students, even the guy from AB, increase the efficiency in 1 HP, 2 HP, 3 HP, and we found the difference in efficiency around 10%. 1 HP in standard motor have efficiency 74%. And when we go on really best design, even with the copper and aluminum, we are able to get 82 and 84% efficiency. 10% increase in efficiency means we are able to encase that panel size will reduce 10%, 12%. It means the cost of the product will not increase. Cost will remain the same, But certainly you can call it, you put the better technology into it also. So with that features we work out all 5. Of course these students are fighting among themselves also. No? Every motor is another student and he says I am better, okay. My motor is better, my motor is better. And we work out of course this in all 5 motors with position sensor initially to work out, but of course we have to put a sensor less. You know why? The motor is already in submersible 100 feet down or 200 feet down. You cannot connect the sensors into it. And these all have to be operated by the inverter or converter, power electronic system, and those are very delicate. You know, for motor, these systems are much robust than normal submersible pump. You know why? The motor is always fed with the very conditioned power, no overload. If overload is there, inverter will tip, motor will not blow. So here the motor is more safe in this system because it will never be connected directly to the grid. Like it's always operated with the inverter. Like so we put of course double stage, single stage, and here unidirectional and bidirectional power. Bidirectional power flow because if you have a larger space, you can put higher number of panels. The remaining power you can put to the grid. If you don't require water pumping, maybe rain season, then also you can put to the grid. It means it not work only the water pumping system, it work as a rooftop power generation also. And you can recover the cost from there also. Because many times you will find there is a lot of additional catchment area. If you talk about the water, the UP Jal Nigam, when it was put in 1970, they put only one tower in around in 1 acre. If you put the panel into 1 acre total, probably it may be around 10 times the generation what you need for water pumping in that. So, there are plenty of applications such in nature that you can even have a lot of generation also in addition to meet the requirement of water pumping also. And typically in Gujarat itself, there was an experiment that the land which even no crop was there, they start growing the banana crop. They put the panel in whole field, entire agricultural field. And power generation was that much, not only feeding probably the pump, but it start putting to the grid. And the banana crop, it does not make difference if you put the panel on 3 meter, 4 meter height. There is no effect. So there are a lot of installation in India and farmers get the money back, typically from the grid also. Also. So all 5 motors, these motors were designed by our student and that get fabricated by Shakti Pump. And we are able to get here also the motor. Every motor in our laboratory, 1, 2 motors, and they tested well in the laboratory. Of course, finally they have to operate it with a proper controller, with already developed by previous student batch. So we start with the induction motor. It worked very well. It's already very extensively used with the normal water pumping. But we work out, and I asked my student to work out using the best intelligence technique that which can typically operate with the water pumping system without, and put the MPPT also in different modes. So we have a grid. We have a different configuration. We take the solar power, we take remaining power from the grid because there are many installations. Like if you have some of the typically a land which have a little sandy, you pump in the day from the solar, but what happen in the night time again it dry up. So you must have a continuous power, means you may take remaining power from the grid even daytime also. And night time you can run with this, and daytime whatever energy comes from solar you can take it. So you can use both without any much problem So we work out of course with the different configuration for every motor, with grid, without grid. These are the all laboratory experimental results. So then we took a solar, and if you have a higher rating of this, you can put to the grid and remaining power can come from the grid. So it means work as a solar plant for the connecting to the grid. If you don't need the pumping, you can put a whole power to the grid. But if you have a less generation, you can take power from the grid to pump. And if you have a higher installation, you can put to the grid as well as you can run the pump. So it includes all the features of rooftop power generation also, along with the water pumping. And motor is more safe because motor is never connected to the grid. It's always connected very conditioned power from this inverter. An inverter, because here we have to connect with the properly sensor and all that and control in a manner, even there is overload, it will stop. But you can understand, this pump may stop, but still power generation will continue to the grid. Even there is a fault on something on the pump or something. So that does not stop the generation. You made a big investment, so you don't want to probably put the complete system to shut down. So it's all we work out in the laboratory with the power quality improvement also on the grid, and it worked very well. And this is of course the second motor BLDC we talk about. Of course, typically this motor really have all the major, you will find plenty of application of this motor like ceiling fan, computer peripherals, all are the BLDC. The number of BLDC in India might be, or all e-rickshaw of around 5 crore in India. The motor used in India may be more than the population of India. These motors BLD in different applications So we consider this motor is reasonably efficient motor for low power rating compared to induction motor. If you talk about 100 to 100 watt, the efficiency of maybe 20% or 30. If you take a induction motor of probably half HP, the efficiency is around typically 65%, but BLDC may be 95% efficiency. So 30% increase in efficiency will reduce the size of the panel by 30%. So makes the sense to put the technology into the field in right direction. So we work out with this also. I mean, typically in the same all these configuration which I talk about for the induction motor, and here also it work out. Typically with the even only with the standalone system also, and as well as part with the grid like. So then we work out another motor, switch reluctance motor, which I'm working since 1990. I mean, when I came in 90 IIT Delhi, we got 2 motors in 1988 in the UK, and with this motor it was close to heart. In 92 I gone to UK and brought a lot of literature on this, but fortunately or unfortunately I couldn't get very exciting students. So now at the fag end I put 7 PhD students on this motor for different applications. Some are sitting here. Of course, I don't know how they will clear their PhD, that's a different issue. But I thought this motor is one of the fantastic motor to work out because it does not use the magnets. I mean, it's a winding on instead of a very typical kind of motor. So it works. So we work out this with this motor also. But something interesting in these motors like BLDC as well as this, we put it that we don't use the pendulum here. We just put the electronics combination which reduces the losses and it controls the DC link voltage. So that further increases the efficiency of this motor, like I mean typically. So then, of course, these are the different operating modes. So this is with the, of course, we took permanent synchronous motors. This technology got revolutionized in last 20 years. For what application? For EV. You know, Elon Musk put for EV the induction motor. That's why the name. Tesla invented the induction motor. That was sentiment. People, he took it. But it's already tested 125 years of it. This motor was not too much exercise. But last 20 years, I mean, you will not believe this motor is researched by so many EV manufacturers. And this motor is considered to be one of the best motor today. I mean, so we thought it, why not to use this motor also? If it has a very highest efficiency and good motor. So we thought it, so one couple of students I put it and one student, and typically, I mean, here we have gone to the industry and manufacture, and this is the typically EV kind of, I mean, rotor, which have a magnetic saliency, but mechanical saliency is not there. Motor can go even not 3000 RPM. For EV, people are going even 20,000 RPM. The advantage there is to reduce the weight of the motor, size of the motor, and losses in the motor. So here also, I mean, the industry is able to go 3000 RPM with this PMSM. They adopted this technology for even for this water pumping system also, like. So here also we work out for all the modes, I mean, like typically, and operated successfully this PMSM also. Then the last motor is the synchronous reluctance, which is offshoot of permanent synchronous motor without magnet. Because people have a fear in the world that magnet is with the China. So if they stop the supply, how it will happen? So this is the offshoot of this with only with the saliency. But today motor is much different than what it was 25, 30 years back. I mean, like also. So this also we work out, I mean, typically, and work successfully with the, I mean, the 3 motors have a similar control, not much different. That's also we got from taking a one converter from the, typically from the industry that, okay, controller can work for all sine fed motor, whether induction motor, PMSM, synchronous reluctance motor. All 4 motor can be operated from the same controller. I mean, the algorithms get automatically get modified with the tuning and all. So another application which really look out with one of my student, how this solar is going to be for EV charging. That if really you have a EV, there is no other way to go without solar because it's the cheapest electricity typically. So we thought of course you will find a lot of concept in the world that with this. But I asked one of my PhD students, like, okay, probably I think this was around 12 years back, I asked, I mean, in the village there may be, I mean, hundreds of e-rickshaw and probably maybe 50 two-wheelers, they have to be charged in that. So major energy should come from the solar with a battery in the ground. Okay, that's a major. But of course you may charge on AC side and DC side, but you must have you may have a grid, you may not have a grid. You must have a small DC set. Why? Because today if e-rickshaw owners and typically two-wheeler people are coming, that we can't say there is no sun today, there is no electricity grid today. You have to still charge them, maybe a small DC set. But of course there was a lot of interesting part that you have to have a synchronization of this, and then you have to feed the additional load also. Because this installation could have been in a small market, okay, small shops. So you have to give electricity to them also, or a small village also. And it worked out a very interesting concept, especially appreciated in IEEE transaction paper. I mean, the guy, whatever paper he written, not a single paper got written. The concept, because it has used lot of control aspect into it, lot of interesting and lot of application point of view. So this we put for small rating, maybe up to single phase can work about 5 to 10 kilowatt. But we work out this, after this we work out for 3 phase also. So we extended for 3 phase, that the major is solar with the battery in the ground, and then you can charge the, I mean, either DC side or AC side the electric vehicle, and put the typically this system to practical applications plenty. Of course, here also a lot of interesting was there, because I couldn't find so much synchronization technique and controlling technique how to connect to the grid, because people were using mechanical switch, but we have to use the solid state switch. And very precise control. Standard say 10 cycle, our students are able to get 3 to 4 cycles synchronization and islanding concept also into it. So with this I would like to conclude and thank you. I mean, these are the some of the references and from where I think our publication start from, some of them, not all. Okay, probably I think students are able to have probably 50 publications, maybe around 20 patent and all. So thank you very much. I hope I am well in time. I mean, like only 219 slides, which I reduced from 500 slides. I mean, like it was my 10-year job to reduce the number of slides. The student want to put everything into it. Okay, sir, this is my friend. His slide is good. His work is good. So you have to put some slide. No, here I have something to give. Around 45 minutes is given to me. So if any question or query is there, then I will be happy to answer.
We have time for a couple of questions.
Yes, sure.
Good afternoon, sir. It was a great lecture. I have a question regarding the solar potential of India that you discussed, sir. The numbers which we have reached or the MNRE has projected, I just wanted to know that how are exactly they calculating it and whether this can be like surpassed through our installations in the future or not. Could you please throw some light on that, sir?
That the first, I mean, they say 3%, I think, wasteland. MNRE data has given in MNRE side. We just selected the data from there.
Okay.
They say so much wasteland. In other application, we have not considered the wasteland. It's only directly we took from there. So you can see from MNRE site and get the complete details of it if you are interested.
So,
Okay.
actually, they had projected 748 gigawatts and you showed 2566 gigawatts.
So we have other, 12 more.
Okay, sir.
Okay.
Okay, sir.
That was one. I can't neglect MNRE. Government of India put thousands of crore to set up MNRE for this purpose. So I have to become, I mean, of course, be in India, so I can't neglect, okay. Even my Uttar Aviskar project, they diverted to, earlier it was approved by Power Ministry, go to the CPRI, but they diverted to MNRE and they have not given single penny. So we have to manage with the MHRD fund as well as industry fund, 3x4 fund, like to the frank. And lot of IIT graduates are sitting there. May not be IIT PhD, but guided by IIT faculty. More than that I will not speak. Yeah, sure. You can sit. You have a privilege to sit. I don't have a privilege to sit. That's why I say I mean, as a faculty or professor, I have an exam every day. And you have an exam only one day, no? Student, especially. Yes.
Hello, Professor. It was an enlightening talk. I just want to know from the renewable energy perspective, why only solar? We have also, can we also change, convert pressure to electricity using some piezoelectric effect? So
Yeah.
that was one question. And also I was wondering if you could have talked a little bit more on wind.
Well,
I'll come
yeah.
back to you maybe
Yeah.
at a offline.
No, let's come for the wind. We work out wind. I have almost guided probably a dozen of students in the wind. Why I have not chosen to talk too much about the wind? Because of the reason, because I have to excite the people here. 40 gigawatt we got 10 years back, and today only it gone to 46 gigawatt. And government India cleverly putting even a small hydro also into the renewable, just to show the data on the website, okay, we have so much renewable. As far as pressure, yes, there is a lot of installation in the world for pressure also. And lot of other energy, typically we call it, I think, geothermal energy.
Yes.
I mean, in my friend in Canada and US, they told me they put geothermal. It cannot meet total requirement, but it reduces the consumption. They have a cycle probably in the ground, 30-40 feet below, and the water circulates. So typically, I mean, I'm not too much in that, but they told me like, okay, they reduce the consumption by around 30 to 40% in the home electricity requirement,
Right.
typically by putting this geothermal.
Right,
That is
sir.
one. And pressure is a lot of places by, the effect, but the amount of energy probably is not so much into that.
Okay.
It depends like now. Here is a more the figure I wanted to put that which energy we should go into the future. We have a big country, we need the big amount of energy required.
Also, any like light for noise, from noise to using some transducer, can we convert from
Yes.
noise to?
Yeah, but I think many of my colleagues from electronics are working what called energy harvesting.
Okay.
There is probably I was in another side of the table sometime in the project evaluation, and they were presenting. So I have to listen. Like they are using converters, what we use it, but their converter rating is hardly watt, 3 watt, 4 watt, 5 watt, okay, even milliwatt, and they convert typically for the sensors. Like even Professor Rangopal, have a startup as well as the project related to. They need a only self-sustaining sensor system where the energy have to be harvested from the environment.
Correct, sir.
So those applications are of very small power
requirement, actually.
but there is lot. So of course those are renewable because they take the energy from the
Right.
environment. So I agree with you.
Thank you, sir.
Hi, BHIM Singh. So, it's a great lecture. I have just one question or need your comment. We in the month of May we had a lecture here by Anil Kakotkar, the nuclear scientist of the country.
I know.
Yeah.
I've been with him in a committee of Indo-US evaluation,
yeah,
and I was very rough with him also because why you put it? They have not generated even a 1 kilowatt. It was 50 crore we dump into it.
No. So what he said that this regarding matching the per capita consumption, comparing with the US, you have to go, as you said, 40 times or 20 times. He says there's no way that you can do this unless you go nuclear. This all renewable, everything will be minuscule as compared to that. This is what his take was. He says unless you do nuclear, you can never reach there, and that will take 100 years at least.
I'm not
So
a bias. I'm not a solar person. Okay, I'm in Department of Electrical Engineering. I'm not Department of Energy, but I can tell you the solar can do it, but atomic cannot do it. A reason, of course, maybe political or non-political different. Agreed. But we are not probably in position to put nuclear at the moment. Probably how many years? Probably 1975.
No. There also he said that nuclear also, if we have to do, we have to go to thorium way, which we have in Kerala. Otherwise, there's no other way. So he says the whole policy has to be changed. This was his take.
But now in global market, material is not an issue. Material anywhere in the world you can have, no problem. Yes.
So, in your opinion, on the usage side, are DC motors the thing to go for? Do you envision long-term appliances running on DC at home, like a refrigerator, air conditioner, or would you propose that we should continue the way it is? And that is for two reasons I'm asking this question. One is the conversion inefficiencies, and the second is the starting current that we have to deal with when you're doing it. So any views on that?
No, we don't use even with the DC, we don't use the DC motor. We use the permanent brushless DC motor, which is more robust and more efficient than DC motor. As a working in a machine like area typically, and as far as DC is concerned, I already have a startup with the name with the Saurya Ujjwala. I asked the name to put Saurya Ujjwala because of the reason that maybe that all the appliances should run on DC, and we observe it. There is around 20% difference in efficiency in the whole system. If you run on DC, maybe 48 volt. You can run directly induction cooker for cooking. You can run the pump on probably directly BLDC motor. You can run the fan with the 48 volt DC volt. Lighting also LED. So the first stage is already eliminated, which really save around 20% energy on the DC. But this will be confined only to a, let's say, home. Typically, Professor, I think Jhunjhunwala is already advocating for last 25 years. But I believe there is a right time of the technology launch. And I can give you an example of technology launch. In 96, GM put the electric vehicle in Silicon Valley, and they become bankrupt in 2 stages. They survive because of the operation from outside the US. And after 10 years, Elon Musk put the EV technology into the Silicon Valley, and I hope you know he is the world's richest man. Are you able to follow? So it's a matter of technology when you really launch. Maybe, I agree with you, probably we have in India a very big scope, I feel it. That's why I was suggesting that probably even a Ujjwala Yojana can be replaced by the solar. Just putting a panel on the rooftop of 3 kilowatt, and that should be enough for cooking and all the needs. Because 3 kilowatt panel will give 15 units electricity, and that should be enough for the needs of in a home in the village. You can put a couple of battery, you can make a very cheap system. I mean, maybe it may come even lesser than the subsidy given by the government. But one have to start. Of course, government have put, I think ASL put already call on the way for this system should be the DC. At the moment, people are putting AC because we don't have a all developed system here. So all the Chinese stuff are dumped into it, and of course the power electronics is very powered by the Chinese. I will not say that they are not good. They are good. If they are not there, probably we could not have done that much. They have given the way to us to survive. So I appreciate the Chinese, but why I appreciate? Because they cannot enjoy what they develop it, and we can enjoy what they develop for us. And we can ask them to design, they can cheap design for us, very well, no. But we have to give our design, okay, this is the requirement of ours, no doubt. But I am very hopeful that this concept will come, not 1 or 2 number, I expect probably maybe same number as the cylinder, gas cylinder given in Ujjwala Yojana, maybe 5 crore, 6 crore. Requirement is 10 crores, not less than that. So I am hoping next 10 years this will come what you are really saying. I appreciate your question. It's very close to my heart. Probably it will come my couple of startups in that direction.
Thank you. If I may ask one more question.
Sure.
So the entire cycle from the manufacture of a solar panel and the savings that it generates and the reduction in pollution that happens, is there any view you have on the overall sustainability of continuing to go solar, right from the production of the solar panel to its end of life?
We have, I think 35 years back we put the panel on Synergy Energy, which Professor Bansal, N.K. Bansal asked me to take over. Professor Bhatti took over, but it's still working. It's a 35-year-old panel on Synergy Energy, is still working very well. So there is no difficulty. I mean, we are the Indians. We will never, throw the shoe when it gets partially, okay. So for India, maybe better technology will come, we will change. I agree that after 25 years, better technology will come. And in solar, I am presuming that every 5-year technology will come very late. Bifacial start coming, you may have we don't know. If PCB came probably 5 layer, 7 layer, the tomorrow solar panel also come in 5 layer. So what you are generating at the moment, like at 15%, 20% may come 100% with the same area. So it's our need, but we know to develop. If we can make the system our use, that's more than enough. Because our requirement is so huge. Let the Chinese should develop or not China. Chinese has a word, big buzzword at the moment, they are developing it, but they cannot enjoy it. They are only the manufacturer, mass manufacturer. We should be user. So we have to dictate them what we need it. Okay, you should make it. What the industry dictate to us that what kind of an engineer we should produce or what kind of a person we should produce and give to them. No? Same thing we can probably dictate to them what we need for. It's only that we have to think about literate up to that extent. That will be more than enough. Okay.
I think we'll stop taking questions now. There is some refreshments on the first floor. So if you have further questions, I request you to get hold of Dr. Singh upstairs in the director's lobby and continue with the questions. Let's have another round of applause.
Oh, thank you. Thank you very much. Okay. हाँ इसको दे दियो उधर बंद कर दो बंद Oh, sorry, I should not take it.